All right. So right now we are going to be doing our hypothesis testing example number 1. You following? All right. So say we have a soda machine. Now imagine that this is a machine that again runs and it fills up soda bottles. Now normally this machine has a mu of 12 and a sigma of 0.05. Mu is the amount of ounces that they put inside the soda bottle, and it could be 0.05 higher or 0.05 lower. That's again your standard deviation, in this case population standard deviation. Now we took a sample this morning of 30 bottles and it gave us a mean of 12.02. A question you may ask yourself is, has there been a change in the amount of soda that this machine puts on the bottles? Now why would you ask yourself that question? Well, because the information that you got for your sample is different than the information for population. Now this shouldn't be this is not unheard of. As a matter of fact, it's very normal because your samples are usually never the same as your population. But the real question that you got to ask yourself is that number significantly higher than that center of the data for us to say that yes, the machine is dispensing, say, too much soda or something like that. All right, so remember there are 5 steps to hypothesis testing. So let's run step number 1. So first thing we need to do is we need to establish our HO and our H1. HO is going to be our null hypothesis, and H1 is going to be our alternative hypothesis. Now, our hypothesis depends on the question that they ask us over here. So the question is, has there been a change? Because the question is, has there been a change, then we're going to set up this as mu equal to the center of the data, 12, or mu does not equal 12. Now, if the question would have been, has there been an increase, then we would have set up that as greater than or equal to, and this one less than. If the question says, has there been a decrease, then we're going to set up this as less than or equal to, and that one as less than. Sorry, greater than or equal to, and this one as less than. Alright, so for step number 2, we need to select our alpha, or a level of significance. Now let's go with an alpha of 0.05. Now remember, for the purpose of tests or exams, this is given to you because the professor wants everybody to kind of run the same hypothesis test. And if you select a different alpha, then you may get a different outcome. So that will be provided. Now for step number 3, we need to figure out which test to run. Now in this case, we're going to assume normality, because those are the only ones that I'm teaching you at this point right now. So we're going to assume a normal distribution. Now once you assume a normal distribution, we need to know whether we know our sigma or not, and in this case our population standard deviation is provided. Therefore we know our population standard deviation, so we're going to be using our z-test, which is x bar minus mu over sigma divided by square root of it. Alright, now once we have that, we need to set up for step number 4, we need to set up our probability curve. At the center of the data, we're going to have 12. So we got mu equals 12. And then in this case, since we're doing a two-tailed test, and we're doing a two-tailed test because we put up here sigma equal 12, that equal means is a two-tail. So equal not equal is a two-tail. So we're setting up a rejection area with a critical value to the right and to the left of our center. Now we're going to put our probability on the outside of 0.05. So we're going to use 0.05 divided by 2 to set up the outside. And then to set up the inside, we're going to be using whatever is left from that. Now to get that number for here, for this probability, I need to take this 0.05 divided by 2. And then when I divide this number by 2, I need to subtract it from 0.5 to get the probability that I want to put here. And I want to put in here is 0.475 and 0.475. Now this number here will tell us what that critical value is. So if you go inside areas under the normal curve and you look for 0.475 inside, you're going to get a z-value on the outside, and that z-value is the one that we need to plug in for our number here and here. Those are going to establish our critical values. So we're going to go to 0.4 to 0.475. Alright, and notice that it's going to be 1.96, but we need to put in there. So we're going to put positive 1.96 and negative 1.96. Alright, now once we have that set up, we're going to run our test statistic with the data that we have. So z equals x bar, which is 12.02. We're going to subtract mu, which is 12, divided by sigma 0.05, and that divided by square root of n is 30. Alright, and the number that I got here is 2.19. Alright, let me run it again just in case. Yep, got 2.19. Alright, now notice that this value that we got here is on the right side of that. Because it's over here, we're going to say that for step number 5, that number is greater than 1.96, therefore we're going to say reject HO. Now if we reject HO, what we're basically saying is that we think that H1 is correct and the number does not equal 12. Therefore, to answer the question, we're going to say, yes, there has been a change in the machine. In this case, it might be dispensing too much soda. Alright, I hope you got this one right, and I'll see you next time.